Okay, let me put the date up here. Today is the 28th of September. So copying DNA is called replication. And yes, if you are using Doceri, boy is it easy. I just keep copying the same darn DNA molecule from one slide to the next, to the next, to the next, which saves me an awful lot of work. So if you're doing this on paper and pen, of course, that's not an option. But one more reason I love Doceri. So we're going to talk a little bit today about what can go wrong. Is anybody here a worst case scenario kind of thinker? Yeah, I am. I'm a worst case scenario kind of thinker. And I don't think of it as a bad thing. And I don't think of it as a mental illness, no matter what a few of my friends have said. I just like to think about what could possibly go wrong and how I would deal with it. So that at the point, if something does go wrong, it's not the first time I had to deal with it in my head. So, you know, when we eat in a restaurant, my family, I always know where the fire exits are. When I am driving over the Chesapeake Bay Bridge on the way to Delaware every summer, I think about how I would get me and the kid out of the car. I just like to know what I would do. So it's nice to know what can go wrong and how to deal with it. That's my approach to life. So we're going to talk about what can go wrong in DNA replication. And I think you know this word. We talked about this a little bit. What do we call it when there is an error in copying DNA? Mutation. A mutation. Good. So now we're going to look at the specifics. So of course the first step in replicating DNA is to do what? Well, we have to draw it straight so that we can deal with it. But the first step in replicating DNA is to do what? Unzip it. Open that puppy up. And I think I said the wrong thing in here. The thing that opens the DNA molecule is called DNA helicase. You don't need to know that, helicase. We're not worried about it at this level. So we open this up, and I've drawn it here, conveniently opened up. And we're going to go ahead and replicate that DNA. Okay, so we're going to go ahead and match these. We're going to do the complementary bases so that we make a complementary strand, except I'm going to throw something in at you. So you know what should go there. And I am going to throw a fast one at you. I'm going to make a mistake, and guess what? Here's what I have to tell you. Right, you already see my mistake? Okay, who else found my mistake? Where is it? Yeah, A and G, those don't match. So that right there is a mistake. It happens. Now, all that happened here was I substituted one base for another. So guess what kind of mutation this is called? It's a substitution mutation. Well, first, okay, this is a substitution mutation. Substitution mutation. Because I literally substituted one base for another. It's pretty simple. Now, because this is something that only affects a single base, there's another name, there's a category of mutations, and those are point mutations. Point mutations. And I'm going to get rid of this whole other strand over here. We don't need it right now. So this is a point mutation because it affects, or it's a change in a single base. Change in one base. Okay, so this one is a substitution. Yes, sir. So that's a point mutation. It's our first type of point mutation. It's a substitution. What do we do in a substitution? We just substitute one base for another. Pretty obvious. Okay, so I've got that same old strand that we started with here once again, because we're going to talk about the next kind of point mutation. There are three categories of point mutation we're going to talk about. So if I'm going along, singing my song, copying this DNA, oops. And I do this. I have an error. Does anybody see it? Okay, I'm missing something in here, aren't I? What should have been there? Oh, I'm sorry, I screwed something else up there, didn't I? There. Is that better? I saw crinkly faces. Okay, what should be in there? There should have been a T in there. I just deleted a base. I just zapped it as though it never existed. This is called, guess what? They're really creative when they name these things. A zap mutation? No. It's called a deletion mutation. Pretty creative. A deletion mutation, which is yet another kind of point mutation. So I deleted one base in there. Now everything else is kind of off kilter. We don't really know why that matters yet. We're going to, by the end of the day tomorrow. This can cause some other problems. So it's still a point mutation. We'll talk a little bit more about the other problems it can cause. Okay, 2 categories of point mutation. I bet you can figure out what the third's going to be. In the third kind, so I'm going to go ahead and I'm going to start making the complement to the first strand. Anybody find my mistake?
Yes.
What did I do?
There's an extra C.
Aha, there's an extra letter shoved in there. It's actually an extra T. There's an extra letter. What is it? Close. It's called an insertion mutation. You could just as well call it an addition mutation. But there's an extra letter. So this is an insertion mutation. An extra letter was inserted. Okay. There's one little extra letter that got inserted. Okay, so the 3 kinds of point mutations. Substitution, we swapped one out. Deletion, a base, we could say got zapped. A base disappeared, a base was deleted. And insertion mutations. We have an extra base, I shouldn't say letter, we have an extra base that got inserted. Now, just like the deletion, where then everything after it doesn't quite line up right, with the insertion, we also sort of cause problems down the line. We don't know why that's important yet, but starting tomorrow, you will. And you'll get a little preview of it in the videos that you're going to do today. That's all that we're going to do collectively. You have got here 2 sheets. Guess how many videos there are linked on Classroom? 2! You guys are so smart. I love it. I've got a good group this year. Okay, that wasn't all that hard. I'll admit that was a softball. So you're going to go through the videos. Like I said, these are one size fits all today. And the first one is a really short little video, but it just highlights the mutations we just talked about. It starts to talk about the idea that things can get off kilter further down when you have insertion or deletion. And then this one is from a group called Amoeba Sisters. It's a little bit more in depth. There is a front and a back. You're going to follow along. They go a little bit, they sort of preview on this what we're going to talk about tomorrow. They preview what DNA is for. What is DNA for? Based on the videos you saw yesterday. What's the whole point of having this like long, stringy, coily thing jammed into all our cells? It's a blueprint for making proteins. It's a blueprint for making proteins. Tomorrow, what we're going to start to talk about is how that protein building process happens. And remember, we're doing all this because we want to know how the heck a bacteria can become resistant to an antibiotic, how a bacteria can exist that isn't killed by an antibiotic. A lot of it has to do with how their cells, I could say their bodies, but their body's just a single cell, how their cell is built. And how their cell is built comes back to their DNA, changes in their DNA, and then how those changes affect the proteins they make and the enzymes they make and other stuff. So that's where we're going. We're just doing this in chunks because it is a weird, complicated topic. So that's it. I'm going to keep conferencing. We've got a few to do, just a couple in here. And while we do that, you'll do videos, viewing companions, and when you're done with that, you can be working on vocab. If you get done with your A and B vocab, if you get done with your A and B vocab, I will be happy to check those off and give you your points. Questions, comments, concerns? Okay.